Alright, welcome. We're going to do an instructional video here on using the NDNA diagram generator. So this video will cover general usage. It'll probably be the first of a two-part series. It'll also cover basically general usage and features, go over the different menus and available features. So without further ado, we'll go ahead and get started. Once you've installed the NDNA diagram generator, you're going to have this plugin inside of Microsoft Visio. It's called NDNA, and there's two menus here. One is the Actions menu here. If you drop it down, there's a lot of different menu items. We'll go over those. Then there's basically a mirror image of that over here. The same menu options here as here, just smaller. The reason there's two of them is that this one under Effects has you have the ability to right-click it and then add it to the quick access toolbar, for example. And you'll see, for example, I've got the expand option, which we'll go over in detail, up here on the quick access toolbar. I've added it there. Then there's two other additional options here that they're always here. They're permanently snapped in there. You can't get rid of them, and we'll go over those as well. One is the View Network Data in Device Browser, and one is the same thing, the Expand option. And the Expand option is also here, and the Expand option is also here, as is the View Network Data. So I'm going to go ahead and get started here, where you would always start when you don't have any page open. So for example, you'll see here we have no existing page open. We're in Visio. So we go to Actions, Start New NDNA Diagram, and we do that. And this also assumes that you've copied the XML file from the NDNA discovery from the Linux virtual machine, from the NDNA VM, via WinSCP over to your Windows host machine, or another Windows machine that you have Microsoft Visio and the NDNA diagram generator installed. So we're going to go ahead and generate a diagram. So you browse to where you have your XMLs, and then it brings up what we call here the device browser. And this is just a view on the XML file. It doesn't include everything that's in the XML file, but it's a specific view of it that allows you to choose a root device. As you see here, shows you the number of connections that the device has. This helps out a lot as you're, especially when you're building, more medium to large size data centers / sites, where you're not going to be building everything at once, and you'll build it incrementally using the expand feature, and probably be stitching together multiple diagrams, or have sometimes very big sites / data centers might have 4, 5, 6, 7 diagrams to cover the whole data center. So this particular site, this first XML that we're going to test on, is small enough that we can build the whole site in one fell swoop. So you'll see here, I'm going to choose, I already know what is the particular core in this device, and you can also tell because it's got 9 connections, and all the other devices only have 1 connection, which is back to the core. So what you do is, again, I'm just gonna, you can highlight different devices. So what you do is you select your core, your root device, which is in a lot of instances going to be your core, but I should say choose your root device, and then you choose the number of levels to go. Here I'm going to choose all. You can choose 1, 2, 3, 4, or every level. If you choose 1, I'm just going to show you. It's just going to put 1 device on there with no connections to anything. So that's pretty much an option that you would almost never use. We'll go back, we'll draw, and actually let me close this out, because you'll see I've got 2 drawings open. So now, because I've already got an NDNA drawing open and I cleared it, I'll choose the next option here, which is Draw NDNA Diagram. And you'll see what this does is it draws an NDNA diagram on the current page from your NDNA Discovery XML file. You must clear network devices first. So this is what this next menu item means, is I'll give you an example here. I'm going to close this out. So if I close it out and I actually have no pages open, then I'm going to draw a new NDNA diagram. That's going to open a new NDNA page, as you see here. Now I'm going to draw this diagram. Now, if I wanted to essentially draw on the same page without opening up a second page, and I'll give you an example here. If I start a new page, I'm going to have 2 pages open now. You'll see there's 2 pages open. So I'll cancel that, and we'll close out that other page that it opened. So now if I want to just draw onto this existing page without opening a second page, and you might want to do this just because you just don't like the way you've laid out the current diagram. So then what you need to do, as it says here, you'll see at the bottom it says must clear network devices first. So I go down to this menu option, clear network devices. Now the page is still open, so now I would choose the second option, which I'm going to draw an NDNA diagram. As you see, it says on the current page. So now I'll do that, I'll choose it, and I'm actually just going to choose all levels, because this particular small site is only 2 levels deep. So it's the core and 9 devices that it's connected to. So we can draw the whole network in one instance there really quick. So now we'll start to go over some of the various options here. We're going to go back in here so we know what start a new diagram is. That's where you'll always start from, as well as if you want to just build additional diagrams and keep the one that you have open. If you want to redraw basically and clear out the existing diagram, clear it out first, and then you can redraw without opening a new page here. Expand is just what it looks like. Well, it's not just what it looks like, I'll have to explain it, but basically what it does is, if let's say I get rid of a device and I go and expand it, it'll add that device back in there. So it'll expand any directly connected neighbors from the device that you select and expand from. So what I want to show you before we go any further is a couple of things on this spreadsheet here, which is again built from the XML. One is you have a search feature. So if I put in here, it's gonna, I just typed in SW1, it's gonna show me anywhere I've got that string. So if you've got a very large XML file with 100 devices or 50 devices, and you're looking for a particular type of device or particular host name and string, you've got a search feature there. The second part is you might be wondering, what's name and host name? How are these different? They look the same. So they are, but how they're different is the host name these are devices that you're able to log into via SSH and Python during the NDNA discovery. So these 4 devices are devices that can be seen by other devices that you over here that you were able to log into. They can be seen via CDP. So these are not devices you're able to log into using SSH and Python. So they're actually not part of the good IPs. So if you've already watched the videos on using the NDNA discovery and post discovery and whatnot, your good IPs are your various IP lists that are created that are devices you could log into, and then you can subsequently perform custom discovery and program the devices and facilitating automation on those devices. But these are devices that would be in your bad IPs. They're devices that you actually could not access using NDNA discovery due to whatever reason. It could be a myriad of reasons. It could be SSH version 1, incompatible SSH version, could have had invalid credentials, device might only be set up for Telnet, etc. Again, this is basically the name here is the name that can be seen through CDP, and that's why. Whereas the host name is the host name that we pulled via the running config. the actual host name configuration parameter. So that's why you'll actually see domain names concatenated, appended here, because you see the domain name as part of this, this CDP information on the CDP neighbor. If it's a device that we pulled the host name from, then we won't concatenate that domain name to the host name portion, or even on the name portion. We'll just truncate that at the dot. So that's what that is. And it's again, if you're in larger environments, or even in as small of an environment as this, it's a good snapshot where you can see right away and know which devices are good IPs and IPs that you could log into, and which were devices that you couldn't log into, but that you still are able to put on the diagram because they were seen by good devices that you were able to log into. They're seen via CDP. Again, those would be devices that are in the bad IPs. So we're going to go ahead and take a look at this diagram. So one of those devices, for example, is this device. So that's why when you look at the one of these devices, you'll see that the only thing that's in the information here is the platform, the interface, and this is the remote interface of the device that saw it via CDP, and the device type. So whereas if you click on any device that you're actually able to log into, now we'll go over what this shape data shows. This is all the information we grab via various Python automation runs that are done as part of NDNA discovery, where it goes in and it pulls all the IPs, whether that's physical interface IPs, which would be here in local IPs, or if it's a layer 3 switch that only has SVIs configured, then it's going to have your SVI IPs here, and you'll see they're all delimited using the pipe sign there. So all the SVIs that are in this core device that I have highlighted over here. And if there's any local management interfaces, they'll be listed here. Again, if they exist. Same with local IPs. Those would be physical interfaces like Ethernet, gigabit Ethernet, et cetera. And then you'll have your code version, your iOS image. If it's an NXOS device, you'll have your NXOS code version, image, and your platform, of course. And if it's in NXOS, you'll have your platform here. And then you'll have total flash, serial number, and then the device type. So you'll see this is an L3 switch object. This is a L2 switch. Here's a router. And so let's highlight another device here. So basically, if I highlight a device, another important piece of information here is the number of remote neighbors shown here and remote neighbors total, you'll see here as 1. But yet, you probably notice here that there's actually 2 interfaces connected. 10.312 goes to gig 10 gig 111, and 212 goes to 10 gig 112. And so back to what I was saying is you've got 2 connections between these 2 devices. There's 2 ports, and but it will only show as 1 neighbor. So the key here is that this is neighbors, not number of connections. So this could be, there could be 10 connections from this device to this device, and you'll see all those interfaces, but on the diagram, and but you're only going to show the neighbor, 1 neighbor here, if in this situation. Another thing that's very important here is you'll notice as I highlight a device, the connection, all neighbors of that device, the actual connector gets highlighted in purple. So if I highlight this device over here, all 9 of those connections will light up in purple. If I click in a free area and unclick that device, those the purple goes away. So once you've built the diagram as well, a few things about the diagram itself is you're going to have the host name, the platform, the device type. If it's a router, it's going to be a round router object. If it's basically a switch that's doing routing, like a layer 3 switch that's running a dynamic routing protocol, it will be a layer 3 switch. Or if it's Nexus, we'll always put the layer 3 switch type of object on there for all Nexus devices. And then if it's like here a 3750, the reason this is a layer 3 switch is it's advertising itself in CDP capabilities router switch, so it's running some routing on it. Next item I want to show is the dynamic nature of the remote neighbors shown feature. So right now, because we built the whole network, let's actually clear this out. We're going to clear network devices. We're going to build a new network, and this is just a much bigger network as well. So a few other things I want to show you as well here is you can of course sort just like you could sort on a regular spreadsheet. So you could sort by name, host name, or by platform, by type, L2, L3 router, or by number of connections, which is very important. So you're going to probably want to use that a lot, where you figure out where your core is, which devices have the most number of connections. So especially again in medium to bigger sites, where you're not going to be able to draw a diagram all at once. It would just be hundreds of connections. It would just be too much insanity going on. You're going to want to start to analyze and evaluate how you're going to put it together. So this is real helpful, seeing the number of connections. So I'm going to start out building this particular, we're going to go 2 levels deep, and because it's a pretty big environment, and I can see this has 8 connections, so it's a good place to start. So this builds that up for us right there. So there's a few things. One of the things we talked about is it building all of these different interfaces that you can see here. There's 1, 2, 3, 4, 5, 6, 7, 8 interfaces. I'm going to just undo that. We'll undo the other one as well. So I'm going to go ahead and actually clear this out and then build it again. So as you see here, we've used this quite a few times, clear network devices. So now I'm going to build on the existing page. We'll draw this same diagram. I'm going to go ahead and build that out. And as you see here, if I highlight it, it highlights all the directly connected neighbors in purple. And of course gives you all your information over here like we talked about. So you'll see a bunch of SVIs there because this is a core device. Same thing over here. And the purple highlights are real nice because it allows you, especially in a big environment, to see how many directly connected neighbors you have. And you'll see here remote neighbors shown, remote neighbors total. So this is what we were talking about just before we opened this, before we closed out the other diagram, the smaller diagram, and opened this one. So if you see here what we initially built here, there's 5 total neighbors to this device. There's only 4 neighbors shown. So this field is actually dynamically updating as you build out the network and expand. So now this brings us to expand. So we're going to go ahead and show you expand. If we right click and we choose expand, it's going to build out that additional device. But what it's going to do, if we highlight this again, you'll see this will have updated. So this dynamically updates from, it had 4 connections before to 5. So now the remote neighbors shown as 5. It dynamically updates as you build the network out using the expand feature. Now what it won't do though is if you go and manually delete an object, let me undo that. If you manually delete an object from the diagram, it will not automatically update the remote neighbors shown. Now the remote neighbors total will always be accurate because that's the total neighbors there, and you want to pay special attention to that. That's something you're going to use constantly and refer to, because that's going to give you an indicator of, how and where you can build the network out, and if there's additional, downstream neighbors. And so let me give you an example here. I'm going to delete this device. Now, if I highlight this, you'll see it did not update the remote neighbors shown. Now there's only 4 on the diagram, but because I manually deleted that device, it doesn't update that. So that's another good reason. Well, there's 2 things going on here. Another good reason to have the purple highlights, so you can then see if that jives with the amount of neighbors shown against the neighbors total, and or I should even just say, just that if it jives against if the number of purple connections jives against the remote neighbors shown. So then that tells you that you've deleted something. So at that point, you can update this. So now I see there's 4 connections. I can manually update this if I want to make it accurate again. So now if I update the remote neighbors shown is 4, there's 5 total, then I know, again, if I expand it now, if NDNA expands it, then it's going to dynamically update. So again, we'll see if we highlight it, it dynamically updates from 4 to 5 connected neighbors. And if we count it, 1, 2, 3, 4, 5. So that's how that works. A couple of things, we went over this menu item. Expand, you can do, it's very flexible, the menus, you can do the same thing in a lot of different places. So let's actually just, we'll expand, this one, there's 3 neighbors shown, there's 4 neighbors total, so I know I can expand this. So again, as we showed you before, you've got expand permanently placed here, so I can expand that there. I'm going to delete that and then show you I can expand it from this menu. And I have to have it highlighted first though. So I can expand from here. I'll delete it. Highlight the device that I want to expand. I can expand it from this menu. Delete it. Highlight the device I want to expand. I can expand it from in the quick access toolbar here where I added it. So you've got a lot of different options for where you can do things. So here I can bring up my device browser here again, and there's a couple of actually really cool options here as well. Is if I right click in free space in the diagram here, I've got 4 different menu options here. One is view network data, one is view data file. View network data is of course the device browser, which is another place to view that the spreadsheet, the XML, but then you can actually view the raw XML file, which is really nice. I use this a lot. So you can say view data file, and it will then prompt you to open it up in your default text editor. So you could also choose to open it up in a browser, for example, in a browser of your choice. I like to view it in Sublime Text, so you could, use a search options, and this is the XML file that the NDNA discovery builds, which basically feeds into the diagram generator. So the diagram generator is designed around this file and the format of these fields to interpret it and construct the diagram for you. And this comes out of MySQL. Basically, it comes out of running automation on the network after discovery, pulling certain information, writing it to MySQL database, then formatting it into an XML to feed into the diagram generator. And so that's a nice feature. Of course, in both of your effects and actions menu, you've got the view data file, which you can view in the same way, or in the same menu here, view data file or view network file. So what I want to try to do, because we're already about 25 minutes in, is start to fly through a few of the other options, and then we'll probably try to end this. We'll try just around a half hour and do a part 2. So one of the things I wanted to go over real quickly here is, this is also in our features and facts, so you can go over that as well, is 5Ks, you're not going to see fabric extenders, or in 7Ks, any N2Ks, fabric extenders, you're not going to see because they're not seen via CDP. They're actually just, basically virtual line cards inside of, a 5K chassis or a 7K, for example. So that's in our features and facts section on the website. You can go over that. The other thing is, adding in, you'll see here, like there's 2 connections here between the devices. Chances are it's probably a trunk and a port channel. So the you basically need to and you can do this all through automation real rapidly. That's the great thing about NDNA, facilitating automation, being able to pull whatever information you want at scale off of the network. So you can show VPC and figure out what Nexus devices are part of VPC domains, and you can get a pretty good hunch of that as well. And I'll give you an example here. I'm pretty sure there's one right here. So like here, if I go and pull this up here, you'll see that I'm just gonna stick it over here. So you'll see, I'm trying to create some separation here. You'll see these 2 devices here. This is probably a VPC domain. Got a couple of ports in between the 2, and based on the name, 5K switch 1 and 5K switch 2 with the exact same name, it's probably a VPC domain, just based on the physical topology. So you're going to have to pull information, show interface trunk, show VPC domains, show IPVRFs, show VRFs, and et cetera, as well as looking at route tables to add in any non-Cisco devices and parsing for those to add in your firewalls, load balancers, whatever layer 3 routing protocols, BGP ASs, IGP, separation and building logical diagrams, all the standard stuff we have to do no matter what as good network engineers. And so I wanted to just kind of cover a few of those things. This type of information is also in the features and facts section of the website. But so let me then hit a few of the more menu options here that you'll run into. So if I highlight a device and right click it, and I do a select this and neighbors, what that's going to do, it's going to actually select this. This is select this device that I had highlighted and all the directly connected neighbors. And you'll see it highlighted every device except for this device down here, because this device is not a direct neighbor of this device over here. And you'll remember this was a device we added in later, we expanded. So what's nice about this is it'll allow you to select all directly connected neighbors, and then you can move it around. And what's nice is you'll see it'll move it around with the exception of not moving other layers of the network that are beyond directly connected neighbors. So you can move sections of the network, the device you select plus all neighbors, but any neighbors of the neighbors of that device stay in the topology and the layout that you have. So that's a really nice feature. So then what you have here is then you have the clear selection highlights that clears it all. So that's what that is again, if I go and I just right click, I can do select neighbors where it'll select all the neighbors, but it won't select the device that you were selecting from. And the same thing, you can then clear all the highlights. Or you can do the select this and neighbors, which will select all the directly connected neighbors and it'll select the device that you are starting from. And again, then you can just move around. Let me do that. Then you can just move around that particular, clear the selection highlights. So if I select this and neighbors, I can then just move those particular devices around and not affect any other devices, any indirectly connected neighbors. So it's a nice, layout feature that you'll find that it really helps you working with building the diagram and customizing it. So this clear all highlights will clear these green circles there, and we've already went over clear network devices. Of course, that just clears all the network devices. And The next thing we're going to go over is and we'll even clear it. So that just clears everything out, and we'll just draw the same diagram again. So if we draw the same diagram from the same position, we draw it, and we are going to show you what cleared dangling connectors is. Okay, so what we're going to do is we're going to expand this device here and show you one more feature here, which is the next feature in that menu item, the clear dangling connectors. So if I have this management switch highlighted, if I right click and I expand it, you'll see it's going to expand that. So instead of 7, now it's dynamically updated. All 13 neighbors are connected. One thing you can do as well here is you can go to Design, Auto Size, and because you're working directly in Visio, it's real nice. You can just auto size it. And if I delete a device here, so I just deleted that, and this is also not going to happen every time. Sometimes all the connectors will remove when you remove it. It's a Visio thing. Sometimes it won't. So if you remove something that's kind of sitting in the center of things, and you will sometimes have where it doesn't delete the connectors connected to it. And again, it's just a Visio thing. So what we added here is an option to clear dangling connectors. So if you do that and you see you clear dangling connectors, it gets rid of all of them. And you can just get rid of this particular device. And again, you might be asking, well, why would I delete that and leave all these hanging in free space? You wouldn't, but the reality is you might delete something where you still have stuff that you keep here, but the connectors that are connected to that device don't automatically delete. So they're just left dangling. They're essentially connected to nothing. So that's why Chris Roth, our developer, built in this really cool feature, clear dangling connectors. So again, as an automation feature and an incredible time saver, it'll just clear all those dangling connectors for you. So at this point, I can go ahead and delete these and be good to go. All right, so next we're going to go over a feature of NDNA related to expand and undo, and the built-in Windows undo up here, where you can undo or redo the last task that was performed. So if we go ahead and expand, we'll go ahead and auto size that. So basically, if you expand, and this is also in our facts and features section of the website, there's specifically a question and answer on this. And basically, if you expand, the undo feature is not supported for undoing an expand. And this has to do with the fact that it's just very unpredictable and generally will not undo everything correctly, because expand is doing more than just one thing. Expand is doing a bunch of tasks at once. So you can use undo if you, for example, move something around. Basically, if you do a single task, anything that you're manually doing in while you're building an NDNA diagram, that's undo is supported. But if you use the NDNA expand feature, undo is not supported. So if you expand something and there's just too many devices, and you realize you didn't want to expand that part of the network now, and you wanted to get rid of all of it, basically what you need to do is just, and of course I'm just left clicking, holding down the mouse and highlighting everything, and just delete it. And just that simple. So again, if I go ahead and expand, and I decide I don't want to keep that, just highlight everything and delete it. There's one other thing here, which is you've got options, and here you can check or uncheck these are checked by default, which are highlight connectors on device select. That's where when you select a device, all the connections of that device are highlighted in purple. And then the other one is highlight shapes on add highlight shapes on selected neighbors. And that's when you right click and you select the neighbors and highlight all those shapes, and then you can drag all those devices. So one other important thing here is you'll notice here there's no X here, and it's just the way the program was developed. So the way you close this if you open it is you just go down at the bottom window here and you'll see the X and just close it out that way. So now we're going to go over one other thing that is very important, and it's a very important feature to be aware of, and because this is basically an error checking that's built in to the NDNA program to get around some idiosyncrasies, if you will, in Visio that might happen from time to time, and they will happen, especially on larger diagrams. So basically, if I go ahead and you'll see here, there's remote neighbors shown as 3. We've got 3 neighbors shown. There's 4. So I know if I expand this device, there's going to be 1 device. And I know we're going to run into this issue with this particular diagram just because I can recreate it consistently. So and this is, again, this is a Visio thing, will happen sometimes. And you want to be aware, you'll be able to pick it out right away. So let me just show you. If I delete this device, I just deleted it, you'll see what happened here is the 3 connections, let me undo the delete, the 3 connections that were connected into this VPN switch 1, they actually, Visio just rehomed them down to this device, which is not accurate. They're not actually connected to this device. So if I delete it and they just rehome down here, the NDNA program has built in error detection, and what that is you'll see that they're highlighted purple, but it's different than when you let's say if I highlight a device and it highlights in purple all of the neighbors. As soon as I unselect that device, all that purple goes away. Whereas you see here, this purple doesn't go away. It has nothing to do with the device being highlighted or not. There's no way to make that purple go away. So that purple, that's there and you'll see here, I'm just clicking in free space here. There's nothing highlighted on the diagram. So if you see purple there after you've deleted something and nothing is highlighted, of course you want to double check to make sure, then these are invalid connections. In other words, excuse me, and makes it easy for you because they're highlighted in purple, then you just manually delete them. And another way to even double and triple check it is if you highlight the connector, you'll see, of course, you've got the name begin and the name end. So this is ATN Lab switch 2 is connected to VPN switch 1, and you'll see totally different device. It's invalid connection. So you can safely delete these, and you want to delete them, and the error detection in NDNA is cross-checking the XML for a valid connection, and it shows you that it's not a valid connection. So that's that. All right, so the next thing we're going to go over is we want to show the inverse nature of the error checking for the invalid connectors. We're going to show you one additional nuance to that, which is basically the same feature but inversely. So it basically, if I remove highlight connectors on device select, and then I get rid of it, you see now if I highlight a device, they don't light up purple. So now if I do the same thing and I get rid of this device, you'll see those same connectors, Visio still rehomes those connectors down to the device below. But because we don't have that option selected, they're not lit up purple. Now there's 2 points I want to go over here. One of them is that we never actually recommend turning off this option because of that fact that it's also an error checking mechanism for you, as well as just a great visual aid to building out the network. And the purple highlighting the connectors on device select. So, but what'll happen inversely, as we see here, if I actually now check off to highlight connectors on device select, and now, of course, that works. So now it works. But you'll see here, if I click it here, they don't light up. So inversely, it's doing the error checking inversely, that it's not lighting up purple because these are not actually valid connections between this device and the 3 devices that it shows connected to. So as it cross-checks the XML in the background, it's not a valid connection, so it doesn't light up purple. So as you see here, these light up purple, these light up purple, etc., etc., but these do not light up purple. So again, this would never be a recommended way to try to identify and reverse check it, if you will, if this happens. And again, this is, it's fairly rare that this happens, but again, it depends on how you're editing your diagrams. If you have big diagrams or you've got a lot of connections and you're deleting devices, you're going to inevitably have connectors that Visio just rehomes those. They snap onto another object. So that's why, the long story short, we just wanted to show you that you want to keep highlight connectors on device select. These are both checked off by default, and the add highlight shapes on selected neighbors, which again is also a great time saver to, and I'm going to get rid of this, and we can just we can re-expand that. We'll add that device back in, that switch, and then these are the 2. You'll see here now we have everything here again. So we never recommend removing that. You want to always keep that checked off, and of course the device select as well is when you select this and neighbors, and gives you that ability to move things around, move the device and directly connect neighbors around without affecting indirect neighbors. So that will do it for those 2 features. As a recap, if you expand the built-in Windows, undo that you'll see in Windows applications like Word, Excel, etc., in Visio, you can't undo that after we're going to clear our selection highlights. So you can't undo that after you've performed an expand operation. If you need to remove those devices, just highlight them and manually delete them. We wanted to show you that inverse nature of error checking for valid connections. So we always recommend keeping this option, keeping both of these checked off, specifically the highlight connectors on device select. And again, it's enabled by default, and that will do it. And we will end this video, and then please join us in part 2 of the general use and features. Thanks.